Welcome to parent function transformations. So there are four types of function transformations. There's f of x plus c, f of x plus d, f of k times x, and a times f of x. The first one is horizontal translation, second is vertical translation, third is horizontal dilation, and the fourth is vertical dilation. So as you can see, there's a difference between the translation versions and the dilation versions of these functions, or of these transformations. The translations have plus on them, and the dilations have times. Also, you can see that there's a difference between the horizontal and the vertical versions of these. The horizontal, everything is included inside parentheses, and the vertical, everything is included outside parentheses. And this will become more important later on. So the transformation form in general is f of x is equal to a times x minus c to the nth power plus d, and n just means some kind of number. It can also be g of x equals a times some trig function, which in this case I'm using sine, of b times x minus c plus d. Now this second one right here is actually more for pre-cal. So if you are in Algebra 2 watching this, then this one doesn't really matter as much to you. Something you might find interesting though is this b represents the horizontal dilation, and it really only ever shows up in trig functions. So first of all, vertical transformations. I have three different vertical transformations drawn here on the graph, and these are absolute value. The top one is absolute value of x, absolute value of x plus 10. The middle one, which is the parent function, is absolute value of x, and the bottom one in blue is absolute value of x minus 10. Now the reason I'm separating it as I say it is to make sure you don't confuse where I'm talking about. So as you can see from the graph, the plus 10 moves the parent function up 10, and the minus 10 moves it down. For horizontal translations, we have the same type functions, or same type form, but this time everything is included inside the absolute value bars. So again, in purple in the middle, we have f of x equals absolute value of x, which is the parent function. On the left, on the negative side, we have f of x equals absolute value of x plus 10. So it actually does the opposite of what you think it's going to do. Plus 10 actually moves minus 10. Now in dark blue, you have absolute value of x minus 10. And the same thing happens here. And the function says minus 10, but the graph actually moves plus 10. So whenever you are doing horizontal translations, remember, you always do the opposite. For vertical dilation, we have a bunch of quadratic graphs here, and they were already labeled. Yes, I pulled this from the internet. That's okay. And if you look, the higher the coefficient of x, in other words, the number in front of x squared, is, the more stretched it is going up. And this is true for all vertical dilations. Now the only difference is down here at the bottom, you can see that you have a negative x squared. And so if you have a negative dilation, it actually flips it upside down. So bigger coefficient, taller graph. Smaller coefficient, shorter graph. Now for horizontal dilation, and this one can only be shown really with a trig function. In blue, I'm not sure how well you can really see it. In blue, you have the original sine function. Sine of 2x, so we've doubled x, actually makes the function closer together. And if we take half of x, which is in the red, sine of x over 2, it actually stretches the graph going sideways. And this is horizontal dilation. So in horizontal dilation, the larger the coefficient, the more compressed the graph is, and the smaller the coefficient, the more stretched it is horizontally. All right, that's it. I kept it just under 6 minutes. Sorry for going over the 5 minutes, and I will see y'all tomorrow in class.